anyway, at the end of the day, when you do analyses like this, and this is partially using our groundwater flow model as well, but you wind up estimating your, I said 120 with the groundwater flow model. We ended up with 160 millimeters a year. We know what's coming out in the streams. We know what's moving to Lake Simcoe, and you start to understand your watershed on a broader basis. And then just some graphs again. Rick put these together. He's working with the Credit Toronto and Central Lake Ontario Committee. But if you look at some of the watersheds, you can see that here's our base flow measurement from the stream flow gauge. Here's our PRMS in this case, our groundwater infiltration. So that's how much recharge we think is going in, and then the discharge. So you can compare the recharge and the discharge. So our groundwater flow models give us an estimation of what's moving out from the groundwater system to the stream across the whole catchment. So you can start to compare these numbers and see how well they match up. And in cases, say the Oshawa Creek, where you have your stream flow gauge is measuring a much higher base flow or groundwater flow component to the stream than what we're estimating is going in from our PRMS model. So there might be something here that water is moving into Oshawa Creek from other watersheds. You can start again. So it's just taking the data, plotting it up, and then thinking. I mean, I think that's one of the things that seems to be lacking a lot of places. It's just people having the time, and it's really a matter of time because there's so many things happening so quickly that people haven't got the time to sit down and really think about the data and what it's telling them. And collecting data too is another big issue. I don't think I have any slides on that. And as I was driving here, I said I got to remember to say stuff about collecting data. There's a great paper from a fellow, Environment Canada, I think. He's wrote a paper that someone put across my desk late last year that talked about this, how this generation of hydrologists, hydrogeologists is the last generation that's collecting data, and now it's turning out that we're taking model output and using it to feed model inputs, and it's just a really clever paper, and it has an analogy to hamburgers and no meat and so on, but it's if you wanted, I could follow up with me, and I could flip it to you in the next slide. Just similar stuff in the Toronto watersheds and the same kind of information, so you can start to see where your models might need more tweaking to better understand the system, or whether you have groundwater moving across watershed divides and so on. So the really kind of simple techniques to try and better understand your system. Yeah.
I know you're trying to understand the model with this, but did you ever take the next step to say, well, if my recharge is happening and it's moving fast down the stream and you lose the recharge fairly quickly, do you ever get to the point whereby I say, well, if I plant trees there, what effect would that have on maintaining that recharge as opposed to letting it dissipate downstream? Or another thing that you might consider is evaporation. Like, how would evaporation come in to skew your models?
Yeah, I think we're going to be moving in that direction. I mean, there's a whole bunch of things I could say. I guess with this PRMS kind of modeling, that ability is now there, and that's probably one of the advantages to moving to these more sophisticated models. If we truly understand how to turn the knobs and the buttons.
Once you've got tweaks done and you've got good data, we don't have a limited amount of time with climate change adaptation to climate change, etc. To understand where the water is disappearing.
Yeah, I mean there's some
droughts or lack of trees is flushing. We're going to probably get some weather flushes.
Yeah. Yeah, there's actually that. I mean, we're in this project that we're just starting. It's interesting. We want to look at that. We've got Trent University involved in this project.
So that's your objective then, is to
kind of take a look at different forested systems. So they're putting in climate stations in a coniferous forest, a deciduous forest, and in just a farm field, and trying to take a look at the differences in because there's an argument that trees actually, do trees increase your groundwater recharge or decrease it? Do they suck the water up, or do they promote more water? And Ireland, there's a big paper a few years in Ireland that they were looking at reforesting all of Ireland, and a lot of people got up in arms saying, holy smokes, that our water supplies are going to dry up, the trees are going to take all the water. So it's still actually an interesting area. I mean, in Canada, we've got the snow melt, or the snowpack, and there's an argument that forested areas keep a better, bigger, thicker snowpack, so therefore more water goes down as a result of snow, which is different in Ireland. So Jim Buttle at Trent University has explored this, and there's some data, there's some neat papers from Forestry Journal, someone showed me a few years ago, on the potholes of Durham Forest. And when they cut down the Ganaraska forest and regrew it, there's some data that I can't remember now which way it points. But anyway, I mean, it's an interesting question, and one that definitely needs to be explored more. Just gotta do something about it.
When you were talking about data or monitoring, the importance of monitoring, is there any standardized protocol or anything that, as citizens interested in groundwater and our watershed protections, any standardized protocol that could be pointed to if it's something we wanted to pursue?
Well, measuring stream flows, I mean, Les Stanfield, I don't know if you've been involved with any of his work, but and the Check Your Watershed Day. Yeah, so the M&R through Les Stanfield, they developed what's he called it, stream assessment protocol or something. So he has quite a detailed protocol that talks about a whole number of things. I think even from benthic sampling to stream flow measurement so that's probably the best the best reference document on it in terms of for citizen groups to look at.
And just to follow up, is there any relationship between, so in a well-based community, while you're working on wells, private wells and things like that, and as individuals, if I'm having, is my well an indicator for the groundwater, I guess is what I'm trying to ask. As my well water is disappearing, does that mean my groundwater is being impacted as well?
You're drinking too.
If I'm drinking less than I used to, but is there any, like, is a well a canary in a coal mine, kind of?
Yeah, well, yeah, for sure. If you monitor water levels in your well, they're, as long as you knock out the bad ones when after the pump has just been on, because you got to be measuring. The best time to measure is first thing in the morning before, you flush the toilet for the first time or whatever, right? So after the evening, when it's probably at its static equilibrium. So that's but measuring stream or water levels in wells for sure is a great data source. Yeah.
Thank you.
I just put a slide in here on modeling, just so I'm not going to talk any more about modeling. I facetiously call it modeling black box, but a lot of thinking, a lot of work goes into developing these groundwater flow models. The pumping rates, stream flows, all the streams are in the model and linked to the different layers in the geology. Recharge rates, and then a lot of geology. In our case, we've got a lot of work done for us by the Geological Survey of Canada through the 1990s that we've taken and incorporated into our